So for today, I'm going to talk about simple linear regression, and which is one of the most used techniques, believe it or not, in statistics and even in machine learning, okay? It is the base of the modeling, I guess. If you know simple linear regression, then the life is going to be much easier for you guys. And also, most of the fancy methods in machine learning and in modeling are as a base, they are using simple linear regression in there, okay? Or some part of it, or some versions of this linear regression in here. And so today I'm going to talk about the residual assumptions and the parameters, and we will fit a linear regression by using LM function in R. And we are going to talk about statistical inference, and then regression coefficient significance test in here. And if you are lucky enough, today we will try to cover predictions in linear regression, okay? So let me briefly talk about simple linear regression. So the most important thing, or maybe you are encountering when you are looking for simple linear regression, is that we should keep in mind that correlation does not imply causation in here, okay? Which is very important. This is the most common mistakes we are doing by using simple linear regression. If you are not really familiar with that method, you will do this error. It is not always, the correlation does not imply causation. Not always. Sometimes, but not all the time, okay? So simple linear regression models try to explain the effect of a particular variable in here. Generally, we call that independent variable in statistics, maybe explanatory variable. Sometimes they call it features in engineering, or maybe you know another name in there, okay? But mainly, I generally use independent or explanatory variable during this lecture. So also we are looking for the effect of that variable on the value of a continuous outcome variable. It doesn't have to be continuous, but for this lecture, we mean continuous outcome variable. And generally we call that dependent variable in statistics or response variable, okay? And maybe you will hear that as target in machine learning too, okay? Do you have any questions, comments so far? Are you guys with me?
Yes, I think everything is okay.
Okay.
Yes.
Okay, perfect.
Hocam, will be the subject similar to 363 class, STAT291?
Yeah, that's, if you cover simple linear regression in somewhere, of course it's going to be similar to that, okay? But for this lecture, I'm mainly concentrating on the implementing the method in R, okay? Not the mathematical equations related to simple linear regression, but since it is a competing lecture, we are just concentrating on implementing in R, okay?
I have a question. First of all, good afternoon.
Good afternoon, Ahmed.
But will the course, like the way that the course is continuing, will it cover more and more methods, or is it gonna like revert back to new structures and stuff? Just asking.
I think I'm going to cover basic steps of regression, but also I will try to put that implementation in graphs. I like visualization, and I like you to see them on the map. And I think mostly I will try to use that one.
Yeah, okay, sure.
Okay.
Thank you.
So it is not a, it doesn't hurt you if you just see it one more time, okay? Because it's a very important topic and it's good to practice. And also your final project will be around, of course, some modeling, okay?
Okay.
So it's,
yeah, okay,
let's look
that's
at
great.
the regression on my side, okay? And how I see it. And of course, there are lots of sources in this topic. And let me first stop sharing my desktop, and I want to share you with my RStudio. Okay, RStudio is really powerful in regression and in modeling. And so first of all, we are going to start with an data set. I'm not sure if you are familiar with it or not. Let's see. We will first use the mass, sorry guys, library in here. And I'm going to use the survey data. Here is the survey data. And if you want to see some more details about these data sets, you will see that it's just contained the response of 237 statistics students in University of Adelaide. And so they just asked they just looking for some number of questions in here, like gender, like a span of your writing hand. Okay, if you are left-handed, then it's going to be your left hand. And if you are right-handed, it's going to be your right-handed there, okay? And they are looking for your span of non-writing hands. And so they're also recording the writing hand of the student. It's going to be left or right. And they will ask you to fold your arms and see which is on top, okay? And pulse rate of students beats per minute. And clap your hand, which hand is on top. And exert, how often student exercise, smoking, height, and whether the student express height in imperial or metric units, okay? It can be in metric or imperial units in here. And then you will see the age of the student. It's a kind of valuable data set. And it's good to get the idea of simple linear regression by a data set, like practicing that. And you can find these data sets in this modern applied statistics with S+, okay? I think some of you guys already know that. Yeah. Am I right? Okay, okay. So here is our data set. We see the first 6 lines. It's up to you guys. And first thing, what we are doing for a data set. When we see a data set, what should you do as a first step?
We might have a look at the scatter plots of of X and Y.
Yep. And also we want to see some descriptive statistics maybe, and see the types of the variables before moving to the graph. And you remember that we can use summary in here. And when you just check out for that one, you can see the gender effect and all the variables in here, like minimum and maximum values. Maybe you recognize that if it is it's a factor and it's just giving you the number of cases, okay, instead of minimum and maximum values. And also, maybe you remember that we were using STR to see the structure of our data set, okay? And here is our data sets. You can just see the structure of your data. And these 3 guys, these are team, okay? These are your starting team, head, summary, and STR. That can be the first step when you want to understand your data, okay?
Okay.
Yeah.
And, okay. So as Leka suggests that we can also get some plot of our variables. In here, since I prepared it before, I will just give you the plot of the students' heights and their hand spans and see if there's any relationship between these 2 guys, okay? And here is my plot. I have my survey data in here. And let's see, I want to see the height, this guy. And also versus, I have my data in here. And I'm going to add written hand, I mean. And let's say you want to add some explanation, like writing hands in centimeter in here. And also, guys, as a YLab, sorry for that, I'm going to add like height, which is also in centimeters in here. And let's see if you want to change the color in here. And let's see, I want to change the color as purple since I like purple. Okay, but of course you can always play with that one. And when you want to run this part, you can always just get this area as bigger. And when you plot this one, now you have your plot to see the relationship between your writing hand and the height in here, okay? And can you say something in here? What kind of relation are you expecting? Just looking for this plot.
There's a
Like,
correlation, like a direct relation. Or like
There's a slightly linear relationship between variables.
I weight a positive linear relationship.
Yeah.
Wow, we are improving now. Okay.
Yes, of course.
And so as you might expect, yes, you are all right, guys. We are just looking for a positive association between that student's hand span and their height in here, okay? And as you said also, these relationships seen as linear in nature. And let's see if you can find or estimate the correlation coefficient in here. And maybe you remember that we are using core function, okay? And just to find this, the correlation between my two variables, I chose already, and this guy. And we should add something to say use complete observations. So maybe you see that the correlation between these two variables are 0.60, and to make you see better. And do you know why we add this part? Do you have any guess?
Because we have NA values.
Yeah, and because there may be some NA values in this vector, and so we have to specify like an optional argument in here. And that means that the statistics, the calculated statistics into account only those observations in the pair of your variables where neither element is NA in here, okay? So it's similar to like NA remove, true. Do you remember we were using NA.remove equals true?
Yeah.
Like when we were fighting.
Yes.
Okay, that's the same thing, but they just put something else in here as an option, okay? So R is going to remove the incomplete pairs when producing a plot like this, okay? So if you want to see how many of them you have, maybe you remember that we had which is NA, and we have survey data dot, come on.
Wow, there's a lot.
There's a lot, yes. And when we just add OR, because we are using two variables in here and it's just looking for the pairs, and that's why I have to use OR and written hand. And maybe I should give it a name like incomplete observation, okay? Why I'm doing that much type. And here is my incomplete observations. And when you check for that one, you can see we have lots in here, okay? We have 29 of them are, let's see if you want to see that length will help you. And we have 29 observations. We have NA values in one of them, okay?
Yeah, okay.
Okay. So after having some idea about our data sets, I want to generate a research question in here, okay? So let's move back to our, where is that? Okay. Let's move to our PowerPoint in here. And let's see, we want to generate a research question in here, guys. Okay, here is my research question. We can just ask to ourselves that what is the expected height of a student if their hand span is 14.5 centimeter in here, okay? And this question can easily be answered by this simple linear regression model. And so we can express that one by looking at this equation in here, okay? So y, this guy means that the value of y conditional upon the value of x, okay? And here is our simple linear regression model. And we want to explain this research question. And also please keep in mind that this is a kind of restricted model because we have some assumptions. Of course, we have some more, but I'm going to talk about the basic ones. We have, for example, residuals assumptions in here. And please keep in mind that the validity of your conclusions you can draw based on your model in here. And they are just critically depending on these assumptions made about your error in here, okay? Your random error. So you are saying that your error is assumed to be normally distributed. And this is how we show that in statistics. That means your error is centered around 0 and your variance is constant, okay? These are two assumptions we are making with our error. And if we move to our parameters in here, if you want to say something about that, maybe you know that your beta 0 is intercept and beta 1 is slope, okay, in here. And or two of them is just called regression coefficients in here. Did I say that? Yes. And so if you want to just interpret your beta 0, and this is the expected value of the response variable when the predictor is 0, okay? But we are not just looking for this guy. Generally, our main interest is on beta 1, the slope, okay? And you said that the change in the mean response for each 1 unit increase in the predictor in here. Okay, guys? This is how we are looking for our parameters or how we are interpreting them. And the fitted model, when you just fit your model, you will see that your y hat, this is your prediction in here, okay? And this is just a specific value of the predictor of x and is written as follow, okay? This is our predicted model or fitted model, I mean. This is your interest concerns. And so we can fit a linear model in R. Let's see how we can do that in here. Okay, R. I want to fit a linear model. Let's give it a name. Let's give, this is my survey data. I want to fit that with a linear model. And as you may guess that we will just use height. Very, very simple example in here. And then by right hand, okay? And here our data, which is survey. I think I did some typo in here. Okay. And you can just write surfeit and see what just has happened in here. And did you see, guys? I have an output in here. Can you see that one?
Yeah.
Who wants to say something about this model?
I don't know why the code is not working for me. Let me try.
What happened? I couldn't hear you.
I don't know why. Like I wrote the same thing that you wrote. I think it's not working. Oh wait, there's one.
I think you write hand instead of H.
Yeah. I wrote hand.
I did the same mistake. Sorry.
Yeah, it's pretty frustrating actually. There's no predictor here. Just need to like wing it.
So maybe you want to write your equation in here. Your y hat, let me write in this way. And your y hat is equals what? What is your intercept?
It's 113.954 plus 3.117 times writing hand.
Yeah, this is your equation. So what kind of interpretation you can do just looking at this one?
For the intercept, as we said, we can say that the expected mean for y when x is 0 is 113.95, And for every 1 unit increase in the writing hand, like centimeter or in X, we expect the mean of Y to increase by 3.117.
Yep, perfect. Actually, in here, the value of 0 for the explanatory variable for X doesn't make sense. Your hand span can't be 0, but still, if it is 0, the mean height of a student will be this guy, okay? And also, on average, for every 1 centimeter increase in hand span is going to be, the student's height is estimated to increase by this guy, 3.1, okay? And of course, we can always add this linear model into our plot. Let's say I have my plot, again, the same guy in here. Let's make it bigger. And this time, I want to just add an ab line. You remember that guy, this function, I think we used it several times before. And we have survey fit, which is our model. You can just write this one and just add some preferences, some options you want to use, okay? I want to choose color as blue, but it's up to you guys. You can just add anything. And when you just look for your graph, you can see that your fitted line is here added to your plot. And this line is referred to an implementation of your least squares regression, okay? And it is the line that minimizes the average squared difference between the observed data in itself, okay? So what does it mean that when you just use survey fit, I mean the linear model in here, R is using the least square estimations in here, okay? That means this line minimizes the average square differences between observed data in here. Do you want to see these differences? You want to add this one on your map, maybe? Or I mean the plot. I use lots of map today. And let's see. So we want to choose just specific records and then add these records on our map in here. I mean the plot in here, okay? So let's first just choose an observation A. And I'm going to choose from survey data, of course. And one of them is my right hand. And let's index that. And I want to just get the 197th observation. Okay? If you just run this guy, you will see a, you will see a number. Sorry again. You see this is 15. And when you, also we want to choose the corresponding y value in here, which is our response variable for the same guy, okay? 197. We have our observation A with 2 values of explanatory and response variable. And also we want to see the observation B. Let's choose an arbitrary number in here. And survey right hand, let's say I want to get 154. And also let's just copy and paste, which is going to be easier, I guess. And again, I want to get 154, okay? Here is my observation B in here, these 2 guys. And so when you just check for the names of your model in here, let's say this is survey fit, you will see that you have coefficients, residuals, and fitted values, blah, 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 okay? So for example, in here, the component called coefficients contains a numeric vector of the estimates of your intercept and slope. Let's say I want to get my coefficients in here. And here is my coef function. And if I just write my survey fit and my coefficients in here is my intercepts and my slope, okay? And I want to just save these 2 guys in somewhere. Let's say my beta 0 dot hat equals my coefficient first one, and beta 0, and I want to get beta 1 and save it to an object, let's say 1, and the second one is my slope, okay, beta 2. And now I can use these two guys and just add some segments to draw the vertical dashed line in my plot. So let's get your plot again. Here is my plot. I'm going to use that guy. And I want to add these two, observation and A and observation B, these two observations. And I want to see if their distance to the regression line, and I want to see that distances on my graph. Okay, then maybe you remember that we were using segments. Yes, that one.
Yeah.
So, yep. Did you say something? No. Okay. No. So let's say I want to add some segments in here. As x0, I'm going to add my observation A, and the first value in there, and my observation B, and the first value, okay? Here. Maybe you remember that we have to give y0 values also, okay? And for my y0, I have beta 0 hat plus beta 1 hat, okay? And times, you should add your explanatory variables in here. Maybe you remember that, them. They are my observation A and observation B in here. Okie dokie. And also for x1, I have my x1. I want to add again observation A1 and observation B. Let's just get this part. And for y1, I have observation A2 and observation B2. And maybe I can just get this part from my code. Here is my 2 and my 2 in here. And so let's just add some more options to WD equals 2 and color equals red. This is up to you guys. So we are going to add these segments for my two observations, okay? Here is my first observation A, and this guy is my observation B. And we see the distance between this observation and your regression line, and again your observation and regression line. And if you add all your distances for all your observations, you will see that this guy minimizes that distances, okay? That's the magic in regression and in least square methods in here. If you are using the least square methods for your regression, that's guaranteeing that, which is very important for us, all these distances from your observations to your regression line are minimized, okay?
Actually, I didn't understand why did we put y0 as beta 0 hat plus beta 1 hat times these observations?
Because you want to see this distance, and one touch is in here, but the second one touch is on y-axis in here, okay? That's why you want to see the value on your line. This is your observation. This is your corresponding value, the fitted value on that one, okay? Y hat.
Okay.
Okay. So maybe you see that we are adding observation, first observations, because there are explanatory variable in here. Did you get the idea, guys? If I add all these red lines from my observations to that regression line, that's going to be minimum 1. Okay?
Yeah.
Yes.
Okay. So we will move to statistical inference after the break, okay?
Okay.
So we have, let me write on chat. Let me first stop recording. So inference is an interesting topic for us. It's special for statisticians. It is why statistics is different than math, because we are also interested in statistical inference in here, okay? It is even different than machine learning methods. They don't have inference, not like us, okay? But if you are talking about the statistical models, of course, they're expecting you to do some inference about that, okay? So what type of questions we can ask in here is that we can just ask that, is there a statistical evidence to support to the presence of a relationship between your predictor and the response? What does it mean that we just said that there's a relationship between them and we just gave this correlation, but they are not enough. You should give a proof, okay? You should give a proof to support your relationship, okay?
Okay.
And also you should give an evidence that a change in your explanatory variable affects the mean outcome. So it is not enough, guys, just to show your graph and say, okay, there's a relationship between writing and hay. According to what? Maybe there is not. Maybe I can say that, no, I don't believe in that relationship, okay? So to make sure that you have to support your focuses, your aspects in here. Okay, guys?
Yeah, okay.
So there is 2 things you can do in here. Good news. You can use significant tests associated with the regression coefficients. And also you can use interpretation of coefficients of determination, which are R squares, okay? They are coefficients of your determinations. So where we can find that is that R is very, very helpful as usual. Always. R is always very helpful. And you can just write summary and your survey fit, and you will see that it's just supplying some summary for your model. And this is your model. It's just giving some statistics for your residuals. And you have some coefficients estimations. And also there are some more information in here. And we will talk about them, okay? So maybe you see that we already get these 2 guys, our intercept and our written hand, I mean the explanatory variable estimation. I mean the beta 1 estimation in here. Did you get the idea?
Yeah.
Yes.
Yes.
Okay, perfect. And of course, R is giving you some statistical values in here, but before moving them, let me stop sharing here and just stop my, share my PowerPoint. And so if we are talking about the regression coefficient significance test in here, we say that the simple linear regression coefficients estimated using these squares follow a t distribution. So this is important. You are estimating by using your least squares, okay? This is the default estimation method in LM function in R. So you are sure that it is using these squares. So if you are using this guy, you can say that your linear regression coefficients follow a t distribution with n-2 degrees of freedom. And the standardized t-value and a p-value are reported for each parameter as we have seen already, okay? And here is our hypothesis by two-tailed. And here is your zero, I mean the null hypothesis. And your truth of high zero implies that the predictor has no effect on the response. So we don't like it. We generally try to reject I0. And your claim in here is that whether there is any effect on the covariance, okay? So as with any hypothesis test in here, the smaller p-value than alpha you determined before, okay? It is a stronger evidence against your high zero. So with a small p-value, this is just reported in our R. And so you see that you will therefore conclude there's a strong evidence against the claim that the predictor has no effect on the mean level of the response in here. Okay, so you just carry out the same test for your intercept, which is not that important, but especially for your slope. Okay, you can just skip intercept part, but you have to do your the test for your slope, and it's typically more interesting. Okay, so since rejecting of that null hypothesis for your beta 0 indicates the evidence that your regression line does not strike the vertical axis at 0 in here. Okay, so you can say that your fitted model suggests there's an evidence that an increase in hand span is associated with an increase in height among the population being studied in here. Okay, so let's go back to our studio. Okay. Let me stop here and let's move to our studio together. And we want to see in here, we want to just check out for confidence intervals. Let's say confint. And here is my model, surfit. And my level is 0.95, okay? That means your alpha is 0.05. And when you just check out your confidence intervals in here, you see that guy. Please remember that we already talked about these p-values because we said that they are really, really small. A to the minus 16 is something like 0. It's very close to 0, okay? You can see that as 0. And so in here, you see that your estimation for your slope is 3.11 and your p-value is really small and you reject your 0 hypothesis, then you find that there's an evidence an increase in hand span is associated with an increase in height, okay?
Okay.
So after that, we can always give some confidence intervals in here. And maybe you remember that we can also do the same inferences by looking at for our confidence interval. Also, by looking at this guy, we can say that you should be 95% confident the true value of your beta 0 lies somewhere between 2.55 and 3.69. Okay?
Yeah.
Okay. So also maybe you see that our output of our summary gives some values of multiple R squared and adjusted R squared. Both of these are referred to as the coefficient of determination. Okay? And they describe the proportion of the variation in the response that can be attributed to the predictor. So for a simple linear regression, let's say like the example we used, the first, I mean the unadjusted, this guy, a measure is simply obtained as a square of the estimated correlation coefficient. What I mean is that, let's try to find it together. If you are looking for your correlation coefficients in here, survey. And please use complete observations in here, and when you just get the square of this guy, you will get almost the same results, just this one. Okay, here is my R square, here is my R square. So this tells you that about 36.1% of the variation in the student heights can be attributed to the hand span. Okay?
Yeah.
Okay.
And also maybe you see that we have residual standard error in our output, which is the estimated standard error of the epsilon term. In other words, the square root of the estimated variance of your epsilon, namely sigma square. Okay?
Yeah.
So you are also provided with a certain hypothesis test, which is F statistics. This is a global test of the impact of your predictors on the response. This will be explored in multiple linear regression, okay? This is not a big deal for us now.
Okay.
Because we are just using not multiple, just single variable in here. Okie dokie. After that, we are always able to find our predictions and to calculate a point estimate of the mean response value. And so we simply plug in with a simple linear model the value of X you are interested in, okay?
Okay.
So please keep in mind that a statistics like that is always subject to variation. So just as with sample statistics explored in earlier chapters, and we use a confidence interval for the mean response. Okay.
Yes.
So let's say you want to determine the mean height for students with a hand span of, let's say, 14.5 centimeter. Okay. Let me write what I am saying. So I want to find the value of beta 0 hat plus beta 1 hat times, let's say 14.5. It's up to you guys. You can just anything you want here as an hand span. I want to look for the value of this one. Okay. If my hand span is 14.5 and my height is going to be 159 as an estimate. This is just an estimate in here. Okay. You can find your hand span. I think it is from here to there, something like that. Maybe you can find your own and just add here and see if it is similar to yours in here. Or I can also predict something else. Let's say instead of 14.5, I just want to see if my hand span is 24, which is bigger. What is my height? It is 1 meter 88 centimeter in here. Okay.
Is there a function to get the confidence interval for what we are,
yeah,
estimating?
I will do that to you.
Okay.
Okay, first I'm just giving you some hard time, then we will make it easier, okay?
Okay.
Okay. So according to this model that you generated, you can expect mean heights to be around 159 and 188 centimeters for hand span of 14.5 and 24 respectively, okay? And this is what you are expecting for. And also we can just find the confidence interval for them, okay? And for this one, R has a predict function to find your confidence interval. So to use predict, you first need to store your X values in a particular way as a column in a new data frame. And so the name of the column must match the predictor you used. And we will let's create something. I want to just check for that one. Let's say I have an X values. This is a new one I will generate. You have to make it as a data frame to use predict function, okay? And you have to give the same name as your variable, right hand. And I want to add 14.5 and also 24 as before. Okay, guys. And here is my X values. Here is my X values. And if you want to get your predictions, confidence intervals in here, let's say I have my prediction confidence interval, and I'm just writing predict. Here is the prediction function. Just add your model, and your new data is your X values that you already generated, okay? And interval type is going to be confidence interval. Let's see. And also your level is 0.95. And by using this function, the prediction function, you are able to find your true predictions. You remember we already found them before. This is maybe an easy way. And also we have some lower and upper bounds for them. So by just looking at these outputs in here, you are 95% confidence that the mean height of a student with a hand span of 14.5 centimeter lies somewhere between 156 and 161 centimeters. Okay. I'm talking about this one. And also 185 and 195 centimeter for a hand span of 24 centimeter. Okay. So this is the confidence interval for mean heights in here. Confidence interval for mean height. Let me write it. Okay. I also have some prediction intervals for individual observations in here. Let me write it too. Prediction intervals for individual observations. So for this one, the predict function will also provide your prediction intervals. And we are just using the same one, like here. Just using the same function. Instead of my prediction CI, I can use just prediction intervals in here. Please just change it, okay? So I'm having the same model and same values, but instead of confidence, this time I'm going to use prediction. This is something different. So just run this part, and I want to see my values. Maybe you recognize that this time you have a wider intervals.
Yeah. So
the intervals described here, row student heights are predicted to lie between 95% of the time. For example, for a hand span of 14.5 centimeters, the model predicts individual observation, not the mean value, to lie somewhere between this, 143, 174. This is a wider interval, okay? With a probability of 0.95. Also, for a hand span of 24, because we wrote 24 before in here, and you see that one, the same prediction interval is estimated at 172 and 204, okay?
Yeah.
So they are kind of different. Please keep in mind that. That's important. And we can plot this data and estimated regression lines in here, okay? We may want to add some segments now for these two guys. Let's say, so maybe I should just send the code to chat because I may not have enough time to write all of them. Let me Where is the chat? Here. I already sent you the code, guys. And when I just run this part, let's say I have my exam, my lab. I'm adding a line, and I have points and segments in here, x0, y0, my predictions. So maybe for segments, I should send them like that. Sorry, guys. Okay, this is my code. This is my first segment. You see that I have 2 of my points. I'm getting my predictions from them. And again, I have my predictions and I want to add them as orange, okay? Maybe not this one. Let's see what happens. Let's see. So I want to plot the data and the estimated regression line, okay? And this time I will use xlim and ylim in plot to widen the x and y limits a little in order to accommodate the full length. And I will add CI and PI in here. And for these 2 guys. And when I just add like plot in here, here is my plot. I have my regression line. I want to add 2 points. You see them? I have my 2 points in here, 14.5 and 24 here, these 2 guys. And also I want to add some segments in here. Okay, this is my prediction interval. I get the prediction interval from here. Okay. And also I want to add 1 more segment to see my confidence interval. Here's another one. And now I will use this time confidence interval. You see that? And now another segment. You see my confidence interval is the interval related to mean value. So this is much smaller. And when you just look for the prediction interval, it's wider because I'm talking about a singular observation. So the first call to segments, the first one, lies down the PIs, the prediction intervals. Okay, they are orange lines. And the second one is the CIs. They are shorter vertical black lines. Okay?
Yeah.
Okay.
So we can do that for all observations. We can add these bands around this fitted regression line for all our observations. Okay?
Isn't it gonna look very messy?
It is.
Yeah.
It is. Let's see. Let me start doing that. Of course, it's going to be kind of messy. And now I have my sequence. This is my data frame. I want to add some data frame. Here is my predictions, okay?
Can you please share the code?
Sure. Here is the code. Not this one, I guess. No. Let me. Yeah, that one. X sequence.
Thank you.
It's just starting from X sequence in here. We are generating a new data frame. We will use these data sets to add some predictions. And first thing, I will just get confidence intervals. And the second one is for prediction intervals. This is my confidence intervals in here for each of them. I have fit values, y hats, and I have lower and upper bounds. And I have p bounds. And this is my prediction interval in here. Okay. So finally,
Yeah.
I can use a graph to add all of them in here, but I'm going to just add the code to chat or to here because it's really, really long and I may not have that much time. And here is the code you can use to plot. And here is, I want to add in here. So we are going to plot something. Hopefully, we will first plot our data and then we are going to add some predictions in here. Okay, here is my second segment. The first one is going to be orange and for prediction intervals. And the second one is going to be for confidence intervals in here. And maybe I can just delete this part. Let me write this one more time because I think it's not okay now. Here is my okie dokie. I have some lines.
I'm so confused. At like the end, at the entire code, I'm a tiny bit overwhelmed. I'm sorry.
Something is wrong, I guess. I hope it's going to work.
So it's basically just repeating the prediction line and confidence interval function for every single point. Yeah.
I mean, for all the, let's see. So I have my points. I have my lines. I want to add 2 points in here and 2 segments. Yeah, something is wrong.
It works with me. I think the problem was that, you know, there are some functions are next to each other. So I just made some lines between them.
I don't know what is wrong in here.
May I send the same code after the...
Sure.
Okay.
Sure, why not? Can you send me just that part? I mean, the segment part here?
Okay.
Maybe it's going to be much easier for me. I think, what is that? What? Oh, I have something in here. Did you see that? Oh no. That's why it didn't work, I guess.
That makes sense.
That makes sense, yes. I had something there. Okie dokie. I hope it's going to work now. So I have my plots, my regression line, my points, and here are my segments for my prediction interval and for confidence interval. Now we have lines around them. And you see that we have our fit and we have our 95 confidence intervals, 95% confidence intervals, and also our prediction intervals, okay?
I think your graph is missing, you know, the...
Yeah, my graph is missing something.
Yeah, the confidence interval part.
Ah, yeah. I didn't add confidence interval bands in here. Like that. No, not this one.
They're all the same color.
Yeah. Let me just add my confidence intervals. And yes, now we have our confidence intervals with blue lines. You see that it's around mean, and our prediction intervals are around our observations. And please keep in mind that the dashed CI bands meet the vertical black lines, and the purple dashed lines, PI bands, meet the vertical orange lines for 2 individual X values from earlier, just as you would expect there, okay?
Yeah.
Okay, that's something I want you to know about regression, and I'm going to move to categorical predictions for next lecture, okay?
Okay.